Hi there. This video is an exam paper walkthrough of the Eduqas GCSE Mathematics Higher Tier Component 1 paper from summer 2023. This paper is worth 120 marks in total, and this is the fifth video of 6. It will focus on questions 18 to 21, which account for 20 of these marks. Eduqas Component 1 papers are non-calculator, so a calculator should not be used. A little disclaimer: there may be more than one way to answer a question. The methods shown in this video are not the only way some mathematical skills can be applied. Okay, let's get started. Question 18a. So we've got a diagram at the top of the page there. It's not drawn to scale, so it's important to remember that we can't measure anything directly from that diagram. So the diagram shows a circle centre O. Points P, R and S, so P, R and S are on the circumference of the circle. Reflex angle POS equals 250 degrees, and that's marked on there for us. But then it continues to give us some more information. So the ratio of the angle OPR to the angle OSR, so OPR, OSR, is 2 to 3. Calculate the size of angle OPR, so we're aiming for this angle here, and you've got to show all of your working out. So first thing we're going to do is recognise that OPRS is a quadrilateral. Okay, that's a four-sided shape inside that circle. It's not a cyclic quadrilateral because all 4 points don't sit on the circumference, but it's still a quadrilateral, and we know that angles in a quadrilateral sum to 360 degrees. Okay, so that's an important thing to note. So I'm going to now start and see if I can figure out some of the other interior angles of that quadrilateral, because then that will help me find the angle OPR that I'm looking for. So I know straight away that I can find this angle here, so angle POS inside that quadrilateral. So here we've got a point, and around a point it's a full circle. So angles around a point sum to 360 degrees. So if I do 360 take away 250, that tells me that that interior angle of the quadrilateral here is 110 degrees. Okay. Now I can use circle theorems to find this angle, okay? And the rule I'm going to use is the angle at the centre is twice the angle at the circumference, okay? So angle at the centre is twice the angle at the circumference. Okay, so that tells me that this reflex angle here of 250 is double this angle here. So 250 divided by 2 is 125. So this angle must be 125. Great. So we've worked out 2 of the 4 interior angles of that quadrilateral. We can't use this fact just yet, but we are going to use this ratio now to help us alongside that fact. So it tells us that the angle OPR is in the ratio with angle OSR of 2 to 3. So whatever those 2 angles should add up to is shared across this ratio. So if I take these 2 angles away from what the quadrilateral should sum to, then it leaves me with an amount I can share into this ratio. So 360, subtract 110, subtract 125. Okay, so that's 360 subtract 235, which is 125 degrees. So this ratio needs to be shared across those 125 degrees. So 2 to 3, so there's 2 plus 3, 5 parts in total in that ratio. 125 divided by 5. Well, 5s into 12 is 2, remainder 2. 5s into 25 is 5. So each part of that ratio is worth 25. So 2 times 25 means that's 50 degrees. And 3 times 25 means that's 75 degrees. Now the question asks us to find angle OPR, so this angle here, so it's this part of the ratio. So make it nice and clear for them. Angle OPR equals 50 degrees. Okay, 18b, we've got another diagram at the top, again not drawn to scale so we can't measure anything directly from it. ABE is an isosceles triangle, so ABE is this large triangle here, and it's an isosceles triangle because these two sides are the same. AB is parallel to DC, so that ABCD is an isosceles trapezium. So ABCD in here is an isosceles trapezium. We have to prove that ABCD is always a cyclic quadrilateral and state any reasons that we use in our proof. Okay, so I'm going to start with the fact that this ABCD is an isosceles trapezium. Okay, because it's an isosceles trapezium, these sides are the same, which means these two angles must be the same. So angle A is equal to angle B, but then these two angles must also be the same. So angle C is equal to angle D. Okay. Now we're going to recognise the fact that AB and CD are parallel. So AB and CD are parallel. So, because these lines are parallel, A plus D must be 180 degrees because they are co-interior. And also B plus C must be 180 degrees because they are co-interior. I best put angles as well just to be safe. There we go. Okay, therefore, because A equals B, A plus C equals 180 degrees. So A and C are opposite angles. And then B and D must equal 180 degrees because C is equal to D. So B plus D, opposite angles. So we're now going to state the rule that opposite angles in a cyclic quadrilateral sum to 180 degrees. So we've proved that it's always a cyclic quadrilateral because of these properties here. Question 19. You are given that y is inversely proportional to x squared when x equals 4, y equals 3. So part A wants us to find a formula for y in terms of x. So we're going to use the information it's given us in the question. Y is inversely proportional to x squared. So y is inversely proportional to x squared. So this then becomes a y equals k over x squared proportion formula. So that's the general form for it. I'm going to use the information they've given me, the two corresponding values. So when x equals 4, y equals 3. So I can use those to find k, this constant of proportionality. So if y is 3, substituting these in, and x is 4. Don't forget to square it here, guys. That's a common mistake that people make in the exams. They forget that it's x squared. So 3 equals k over 16. So k must be 3 times 16, which is 48. So now I'm going to rewrite this general form here, but with the k value included. So y equals 48 over x squared. And that's my formula for y in terms of x. Okay, part B and then part 1. Use your formula to find the value of y when x equals 8. So I've got this formula here, y equals 48 over x squared. When x equals 8, I want the value of y, so I'm going to substitute 8 into this equation. Remember that on the bottom there it's x squared, so I'm substituting in 8 squared. That gives me 48 over 64. And when I simplify that, I get 3 over 4. So y equals 3 over 4 or 3/4 when x equals 8. Okay, B part 2. Use your formula to find the positive value of x when y equals 1200. The fact that it mentions a positive value makes me think, oh, maybe I'm going to get two values here. And then that's prompting the thought, well, if I'm going to get two solutions to my equation when I substitute something in, then that potentially means I'm going to be working with a quadratic. So if I see a quadratic appear in my working, I'm going to be quite happy because it means I'm on the right track. So we're working when y equals 1200. So we're going to use this general form again, but we're substituting in y equals 1200. So 1200 equals 48 over x squared. Now we're trying to find the x value. So first thing I'm going to do is I'm going to multiply by x squared. So 1200 x squared equals, and then I'm going to do the same on this side, 48. Okay, now I'm going to divide by 1200 because I'm aiming to get x. I'm aiming to isolate x. So divide by 1200, so x squared equals 48 divided by 1200. Now when I simplify that, x squared becomes 1 over 25. Okay, I did quick maths then, but you could go divide by 2 until you get to the point where you're at your simplest form. But I wanted it to be here because that looks nicer for me to work with because I'm dealing with an x squared. So to isolate x and get the value, the next step is going to be to square root, and I can square root both of these numbers nice and easily. Potentially I couldn't square those ones nice and easily. I'd have to be simplifying surds, and as I'm okay with that because surds is one of my favourite topics, this is just going to make my life easier in the exam time-wise. So x is equal to plus or minus, remember, whenever we square root, there is a positive and a negative value to that. So it's plus or minus the square root of 1 over 25, which is plus or minus square root of 1 is 1, square root of 25 is 5. We want the positive value, so we're just going to tell them x equals 1 over 5. Question 20, write 3.21 recurring as a fraction. Give your answer as a mixed number in its simplest form. So this is recurring decimals to fractions. So I'm going to start by just saying that x is equal to this value, 3.21 recurring. Now note that the recurring symbol is above the 2 and the 1, so it means that it's the 2 and the 1 that repeats in that pattern. Okay? Now I'm going to make a multiple of x. So I'm going to scale it up to make a multiple of that. I'm aiming to have the same thing matching after the decimal point. Okay, so if I was to multiply this by 10, everything would shift across one place to the left. It would become 32.1212. Well, that won't match exactly here. So if I show you that, look. So 32.121212, okay? My decimal point afterwards doesn't match. If I was to do 100x, so let's get rid of that one, everything shifts across two places to the left, so that becomes 321.212121. And what you'll notice here is after the decimal point matches exactly, and obviously this one would continue. So when you're finding your multiples of x, that's what you're aiming for. So you might start with 10x, but if it doesn't match exactly what's repeating after the decimal point, you can't use those multiples to solve this problem. So now I'm working with 100x and x. So I'm going to do 100x subtract x. So 100 subtract 1 is 99. So I have 99x. And then 321.21 recurring, subtract 3.21 recurring. Well, the 0.21 recurrings are going to cancel out. And then I'm doing 321 take away 3. Well, 321 take away 3 is 318. Now I'm going to divide by 99. So x equals 318 over 99. And what I'm going to do then is I'm going to see if I can simplify. Now I can divide numerator and denominator by 3. 99 is in the 3 times tables. And I know 318 is because 3 plus 1 is 4 plus 8 is 12. And that's in the 3 times tables. So when I divide them by 3, I get 106 over 33. But now I'm not finished. I need it in its simplest form as a mixed number. So I need to see how many 33s go into 106. So 33, 66, 99. So that's 3 of them. And the remainder to get from 99 to 106 is 7. So that's 7 over 33. And that's my answer. Question 21. In this question, all lengths are in centimetres. So that's important to know. We're working in centimetres. We've got a diagram here, a rectangle. We've got one of the side lengths labelled, and the diagram's not drawn to scale. Again, important, we can't just measure anything from a diagram. So the length of the rectangle is root 5 add 3. They've got that on the diagram for us. The perimeter of the rectangle is 8 root 5 subtract 2. So the sum of all of the sides is 8 root 5 subtract 2. Calculate the exact area of this rectangle. So the word exact simply means that we're going to be dealing with something, or one of our answers written in third form. Okay, so it keeps it nice and exact. We don't have lots of messy decimals trailing on the end. So we're aiming for the area. So for the area, we need to do length multiplied by width. We know the length of the rectangle. We don't know the width. However, we know the perimeter. And to find the perimeter, we would do 2 lots of the width. So it would be so the perimeter would be 2 times the width plus 2 times the length. Well, the length is root 5 plus 3. Well, if the total of those, the perimeter is 8 root 5 subtract 2, then if I subtract this, the 2 lengths, it'll tell me what the 2 widths are worth. So let's do that. So 8 root 5 subtract 2, subtract 2 root 5, oh I can't write, plus 3. Okay. So this is the important thing now. We're going to expand that bracket and we're going to be really careful with our signs. So 8 root 5 subtract 2. So negative 2 times by root 5. So that's the first bit here. So that's negative 2 root 5. Negative 2 times by positive 3 is negative 6. Really be careful with your signs there, guys. So now we're going to collect like terms. So we have 8 root 5 subtract 2 root 5. Remember, we can add and subtract surds exactly the same way as we collect like terms with algebraic variables, as long as the surd matches. They're both root 5, so we've got 8 of them, subtract 2 of them, so we have 6 root 5 in total. And then we're going to deal with negative 2, subtract another 6, so it's getting more negative, so that becomes negative 8. So this is our 2 widths. Well, we only need 1 width to find the area because we do width times length. So I'm going to divide this by 2. So this becomes 3 root 5 subtract 4 because 6 root 5 divided by 2 is 3 root 5. Negative 8 divided by 2 is negative 4. So this is our width. So now we can calculate the exact area by doing the length times the width. So area equals length times width. So our length is root 5 plus 3. Our width is 3 root 5 subtract 4. And we're going to expand these brackets. So root 5 times 3 root 5 becomes 3 root 25. Root 5 times negative 4 becomes negative 4 root 5. 3 times 3 root 5 becomes positive 9 root 5. And 3 times negative 4 becomes negative 12. Now we're going to simplify this a little bit further. So 3 times root 25. Well, root 25 is 5, so that's 3 times 5, which is 15. Negative 4 root 5 plus 9 root 5. So we're collecting like terms again here, guys. Negative 4 root plus 9, negative 4 root 5 plus 9 root 5. So negative 4 of them, we're adding 9. So we're going to get plus 5 root 5 here. And then we've got that negative 12 on the end. I'm going to simplify a little bit further because I can collect like terms with these constant variables here. So I've got 15 subtract 12, which is 3, plus that 5√5. So that's our area in exact form. Measurements are in centimetres, so I'm going to pop centimetres squared there.